Welcome to the University of Kaiserslautern in our beautiful new laboratory building in our Smart Energy Lab here. My name is Carsten Gloser. I have been working here at the University of Kaiserslautern for 12 years in the field of basic electrical engineering and regenerative energy systems. In 2019, the idea was born to present the entire chain of electrical energy generation in the renewable and conventional sectors, from transmission to utilization, to students in a laboratory experiment or in several laboratory experiments, and to integrate it into our teaching. The background is that we are located at a former industrial site. The University of Applied Sciences Kaiserslautern got some new buildings. The state of Rhineland-Pfalz financed the whole project. We have received a new laboratory building here with nearly 10,000 square meters of laboratory space equipped with the most modern facilities. In a University of Applied Sciences, a high proportion of practical experience and especially laboratories are an indispensable part of modern engineering education. Even though today much of it could actually be simulated on the computer, practice is still important. And that's where the idea was born for us in 2019. And as it is with such ideas, you develop them further, and yes, then such things initially always fail due to money. That means we had to see that we mobilized the necessary money for it within the department at the university. We definitely largely succeeded in that. Then we got in touch with each other. I am delighted that Lucas-Nülle has supplied us with this training system in the year 2023, which we can see here in its full functionality.
How did the commissioning of the training systems go for you?
Smoothly, completely smoothly. Worked out great. Within 2 days, the entire lab was set up, partially put into operation. Commissioning is still ongoing, and now we are looking forward to the training.
What added value do these training systems offer you?
Well, as already indicated, it is important and it is an indispensable part of engineering education that one also does something practical. You have to use measuring devices, you have to use cables, electricity has to flow, you have to see something and also have the opportunity to make a mistake. We always have these discussions when it comes to the fact that such a laboratory is correspondingly expensive, the equipment is expensive. Theoretically, one could save on it, one could simulate everything, but that is not the same. Frontal teaching is no longer what is considered contemporary today. Here, with our new building, we have the opportunity for the first time to truly implement completely new teaching and learning concepts in practice. So we run laboratories no longer as independent labs, but rather link the whole thing with teaching and integrate it into regular lectures, up to student projects, term papers, thus perhaps moving away from classic exam situations so that projects can be assigned here. And this Smart Energy Lab is indeed a very important and extremely crucial component, a very important part of it.
Can we speak of real experience learning here?
In any case, it is important to note that especially the unique combination of advanced simulations and cutting-edge devices that are actively running here provide students with a valuable opportunity to practically implement and effectively apply the various things they learn in a theoretical manner during their lectures. To experience hands-on training combined with lectures, this is how we will use the laboratory here in the future so that proper lectures will also take place here. So no longer classically in the lecture hall, but really connected with practice here.
Can you imagine integrating more systems from Lucas-Nülle into the laboratory in the future?
Yes, as I see it here now. We do indeed have a very extensive and detailed, comprehensive system, but there are still things we can expand here, like the small wind turbine system. We also have parts outside that we want to integrate. Our students, together with the architects, designed and built a tiny house the year before last. There is photovoltaic available, there is a heat pump available, storage system. We plan to collect data and feed it into the system for shared use. We also want to integrate the tiny house that is outside, possibly supplemented by a small wind turbine. This way, the system is not only used for educational purposes, but also linked with real data. And I can also imagine integrating extension systems such as those from Lucas-Nülle here, implement projects, complete their final theses here, and do it all with real data that we would like to incorporate. And I can also imagine integrating extension systems from Lucas-Nülle here.